Okay, once again, here we are trying to state the domain for a function, but are presented with sort of a combination of issues that we need to safeguard against. Number one, we need to protect the denominator and the values that are going to cause this denominator to be zero, thereby making the entire fraction undefined, are hidden within this expression. If we break it down using factoring, we'll be able to tell what those values are. The other thing that needs protection, because it would also make this fraction undefined, is if we allow the radical to turn into an imaginary number. And you know that happens when this value is negative. So we're going to stop this from being negative by protecting the expression 3x minus 6 also. Okay, first I'm going to go after the denominator and find out what valuables are not, or what values, excuse me, are non-allowable. So let's figure out what would make that denominator 0 and then actually find the values by factoring. We would break up the first term as x times x. Then as part of a two-step thought process, you'd be thinking what two numbers multiply to give you 15, but also add to give you negative 8. Those numbers would be negative 5 and negative 3. And you can put the negative 5 up here and the negative 3 back here if you choose. Check it real quick. That's why this is called guess and check. You should be able to multiply those to get this. You can. And you should also be able to add those two numbers, negative 3 and negative 5, to get negative 8, which also works. Then to figure out what values would make either this factor or this factor equal to 0. You can tell that just by observation. These expressions are simple enough to do so. The value that would make this expression 0 would be 3. Therefore, 3 is a non-allowable value, because if it makes this factor 0, it makes the whole expression 0, and this factored expression represents this denominator. The value that would make this factor 0 would be x equal to 5, and therefore that is a non-allowable value. So at this point, we know 3 cannot be used, 5 cannot be used for input of x. Now, to protect the numerator, we're going to make sure that this does not turn into a negative number by forcing it to stay above 0, because anything above 0 is positive, or at 0. It can be a 0, this value. It can be equal to 0 because that's not negative. We just don't want it to be negative. So by doing this, we're protecting this. Now we're protecting the radicand, which is inside this radical. And now let's solve that. We're going to add 6 to both sides to see what x values force this to happen. 3x minus 6 being greater than or equal to 0. We're now going to find the values that will allow that to happen. Add 6 to both sides. You have 3x greater than or equal to 6. Divide by 3, and you get that x is greater than or equal to 2. So in order to protect the radical, we need to do this, and we found out the values that achieve that are anything greater than 2, greater than or equal to 2. We also found out that 3 and 5 are not values that we're allowed to use. Let's dump all of this information on a number line so that we can properly state the domain. Okay, so we know that I'm going to put open circles on the 3 and the 5 first, and then I'll do the shading of x is greater than or equal to 2, making sure to skip over 3 and 5. So this will be 3. This is going to be 5. Cannot use that value, and therefore the open circle. Cannot use this value, and therefore the open circle. 2 would be over here. Now that actual value of 2 is allowed, so I will shade that in, and here I go, shading to represent greater than. So I'm going all the way to the 3, but I cannot use the 3, so I jump over it with this open hole. When we go to do interval notation, that can be stated using a union symbol. Then everything between 3 and 5 can be used. That's okay. Jump over the 5, and then anything to the right of 5 can also be used. So these are all allowable x values. 2 to 3, including 2 but not 3. From 3 to 5, including not including either one of those endpoints, but everything in between, and then all of the values from 5 to infinity, but not including 5. Stating that in interval notation, we read these allowable and non-allowable numbers from left to right. So starting with 2 is allowable, which is why I've put it in a bracket, all the way to, I'm naming the interval 2 to 3. 3 is not allowable. Jump over the 3 using a union symbol. Then state that all the values from 3 to 5 are allowable, not including either of those endpoints. Jump over the 5 using another union symbol and state the other interval numbers that are allowable from 5 to infinity, not including the 5, and then all infinity symbols have an open interval notation around them. And that is the domain.